Right, here we go. That is a video on how to do the student t-test, or the t-test. It's to go with 8.3. Right, let's have a look at this. It's initially it's a calculation. You'll get to a value that you're comparing to a value from a table, and then you're making sense of the entire calculation. So in some way, it's not very unlike the chi-square that you just did, but careful, it is a different lookup table, and the interpretation is a different interpretation as well. The key thing you're trying to get to is you've got two sets of data, or more, but for this case, two sets of data will do. And between those two sets of data, you're trying to see, is there a statistically significant difference between them? Or is it just random fluke a little bit? It came from a background, actually, weird enough. The t-test has got something to do with Guinness and brewing, and the brewery chief behind that, the person who actually came up with the t-test, was not allowed to publish it because he didn't come with a mathematical degree. That's why it's also sometimes known as student t-test. He has to publish it as a student. So let's have a look at how it's being done. So we'll start initially. Yeah, so the test is to find out if there is a statistically significant difference between two sets of data. So put yourself in the situation, you're a brewer, you want to get your barley from the best field around. You have got 3 or 4 different farmers pretending or saying that their field is growing the most, the highest or biggest grain of barley, and you want to buy one of those fields. Now, one farmer is selling it a bit more expensive than the other and is claiming that, hold on a second, we are actually having a higher crop yield. Is it statistically significantly different? That is what you're trying to find out. You're going to need a mean and standard deviation and the number of how many sets of data you have looked up. So you might want to use Excel to get these numbers together. You know how to do the STDiv by now in Excel. So here is the scenario. You have got plants, corn or barley or whatever it is you're growing, and you're suspecting that there is a statistically significant difference. Not just that might be just a touch bigger, but actually it's not significant. This is now mathematically proving that it is definitely bigger. It's not just a little bit of a random, slightly bigger, slightly less. So let's say these ones are the sets of data. You've got the south-facing data, you've got the north-facing field data, and the size of your corn or your barley or whatever it is that you're growing. By just glancing at those numbers, you might already guess a little bit. It should be south, isn't it? It should be looking at the numbers of north. There's some really small ones in there. We could just compare the means. We could compare the averages to means. But that doesn't tell us, is it statistically significant? So if you just look at the data as dots against the number line, it's kind of also becoming a little obvious that the red ones and the yellow ones, yeah, seems to be not the right distribution. Just like with the chi-square, you will need to formulate your hypothesis and your null hypothesis really carefully. Make sure you use those right keywords and rephrase it in the way that it's needed. So for this scenario, where you've got a north-facing field and a south-facing field, the hypothesis is that there is a statistically significant difference between the height of plants in the north-facing and the height of plants in the south-facing field. Now, the null hypothesis will always be the opposite. There is no statistically significant difference between the height of those plants, north and south. So that there's, yeah, they're actually just fine, similar. Okay, now you are a bit like the chi-square. You're going about, can you prove the null hypothesis wrong? In case it's wrong, you can say the hypothesis was correct, which means that there is a statistically significant difference. So how do we prove that wrong? Okay, you will need, like I said earlier, mean, standard deviation, and the number of items that you've had. You can do it by hand, or you can just do it on a spreadsheet, because we've done this now before already. So if you're doing the spreadsheet, you know how to do standard deviation, STDiv, with the function button again. So that should not be new. Otherwise, go back to the PowerPoints that we've had for 8.1. Okay, so collect all the data that you have collected for this one. Now, can I just go out of this PowerPoint? I wanted to show you on the worksheet that you're supposed to be using as we're going along. Oh, I've scrolled to the bottom of the worksheet. this is for you to fill in as we go along with this PowerPoint, or do it separately afterwards while you go through the PowerPoint, to kind of phrase your hypothesis and null hypothesis correctly, okay? You will need the mean again, which was the X with the line over the top, the standard deviation, and the number in the sample. And the symbols that you're going to be using is S for standard deviation and N for the number in the sample, and X. Now you've got two sets of data. You've got the south-facing data, you've got the north-facing data. The south-facing data is always when you have got a little number 1 next to it, and the north-facing is always when you've got the little number 2 next to it. Just be consistent. You can do it the other way around, but do it consistently, okay? Right, let's go back to the PowerPoint here. Right, now you've got all your information together, and it's literally the number in the sample. So you count them, okay? That's not magic. The formula looks a bit scary and freaky, but you know already that if you take it to pieces and do it nice and slowly, it actually isn't that bad. The worst thing about this here is actually calculating it right once you put the numbers in, because it is getting a bit spooky. You will need to start with the fractions that are underneath the fraction line and underneath the square root. So do this fraction, calculate it out. Do this fraction, calculate it out. Add them together. Square root of it. Make sure you write those numbers down. The slower you go here, the less likely you will mess it up. There's a good chance that if you're rushing and you're forgetting to do your big maths the right way around, that you're going to end up in a mess here. Now, you will have new symbols here that look a bit like, oh, what do I do with those? So this was the mean, or the average, the mean for your south-facing plant. Take away the mean for the north-facing plant. Now, theoretically, taking one away from the other, you could potentially end up with a negative number. Now, with chi-square, what we did to get rid of those negative numbers, you square it and then you take the square root of it. This straight line bracket, it is literally a bracket, means whatever you're calculating in here, just make sure it's positive. That's all it is. So if you are calculating 4, take away 5, you would actually get -1. Your answer is +1 because it's in those straight line brackets. So just that you know what that new symbol here means. Okay, let's go through this nice and slowly. Okay, why does that not doing what it's supposed to do? Okay, at the top of the fraction line, this is what those 2 bars mean, that you are always subtracting it in a way that you are getting a positive number. Okay, once you've calculated that out for your numbers, this is the value you're getting to. Please follow that and practice that yourselves, because once you get to the real thing, there's no chance to check on yourself whether you're messing it up before you're submitting it. So here, practice it yourself and double check. You know that the answer sheet is already uploaded there in Shobi, so just try it yourself first before double checking on yourself, okay? Now, the bottom of the formula is complicated, okay? And careful, this here is actually a square root that goes all the way to the bottom, so it's a square root of the entire thing. It's a bit hard to get the PowerPoint to do the right thing here. So it would have to be, you're taking your standard deviation of the sample A, which is 0.18, square that, then divided by 8, which gives you this number. Take this, square it, then divide it by 8, that number. Add them together. Once they're added together, then take the square root. Serious, go slow and follow the big maths correctly, okay? So if not sure, come back to this PowerPoint and just remember that this actually is a square root that goes all the way down here. Now, don't forget, you've actually not finished the final division. It was a division, and you've calculated the top number beforehand. Now you've got the bottom number, calculate it out, and ta-da, this is your t value, your calculated value. Now, from the calculated value, you still need to go and look up. Let me show you the lookup table before you've got the whole, what do I actually look up? This table looks different, okay? First of all, it says t-test at the top and not chi-square. You will need to use the right lookup tables. Please don't model those up. The t-test table, hold on a second, probability. What probability did we look up for science before? We did look up 95 before. That is the scientific standard. So we'll need to be somewhere in that probability column here. Now, what degrees of freedom do we have? For this situation, what you want to look at is your original data set. how many sets of data did I actually have? I had 1, 2, 3, 4, 5, 6, 7, 8, and another 8 makes 16. However, a bit like the chi-square, you're going to get one outcome for each of them anyway. So you're going to get one number for south and one number for north anyway, which means that you've had in total 16 values, but you've got 14 in addition that you could get. So the way you're getting your degrees freedom is, let me go back to that slide here. Slideshow, here we go. The way you get your degrees freedom is the total number minus how many columns you've had. In that case, it's minus 2. Now you've had 8 measurements in each, would make 16. Take away the 2, you'll get to look up 14. So let's go to the t-test table here. 14, we're going to look up, here we go, 95. We're going to go down here. That's the 2.14 value that we're looking at. So you have looked up a 2.14 value. That's this one here. Right. Now comes the rejecting and accepting. And it's a bit like the chi-square. You reject the null hypothesis if your value, the calculated value, is larger than the critical value. Now, what have you calculated? Calculated 3.277. You have looked up 2.1. Okay, the value of 3 is bigger. So it's a larger value, therefore you reject the null hypothesis. The null hypothesis was that there wasn't a statistically significant difference. That now means we have to accept the hypothesis, which means that there is a statistically significant difference between the plant height on the north or on the south facing field. You should be able to get ahead with it now with the assessment task. Please make sure you are going back to your PowerPoint, particularly when it comes to phrasing your hypothesis and null hypothesis. That's slide 7. And also towards the end, when you need to interpret, when you need to make sense of, hold on a second, we reject if your value is larger. Otherwise, you have to accept your null hypothesis and say, actually, no, there isn't a statistically significant difference. Right, let me know how you're getting on with this.